Imagine an AI system trained to understand whale song, not by decoding meaning, but by detecting patterns. It identifies recurring melodic motifs, tracks changes over time, and even predicts the next note in a sequence. It performs with astonishing accuracy. But what if the very structure of that AI's intelligence is incompatible with the way whales communicate? This isn't just a technical glitch. It's a philosophical crisis, one that emerges when one recursive cognition, built by humans and trained on human data, encounters another recursive cognition shaped by evolution, ecology, and culture in a different species. We call it the double contingency problem. The fact that every species, communication arises through contingent recursive processes, shaped by their environment, social dynamics, and evolutionary history, while AI systems process those signals through their own contingent architectures, training objectives, and recursive loops. The result? Not neutral understanding, but a collision of cognitive worlds. Let's unpack this. At the heart of modern bioacoustic AI are transformer models, architectures designed to process sequences through recursive attention mechanisms. Each layer builds on the last, refining representations through iterative feedback. Training involves optimizing parameters based on prediction errors, creating a loop where the system constantly adjusts itself. These aren't universal tools for pattern recognition. They're recursive cognitive agents shaped by specific human design conditions, datasets, loss functions, evaluation metrics, and architectural choices. Now consider an elephant herd moving across the savanna. Their infrasonic calls, low-frequency rumbles below human hearing, aren't just signals. They're part of a recursive system. A call triggers a response, which shapes the next call, which carries memories of past encounters, migration routes, and family bonds. These patterns unfold over days, even weeks. They're not static features to be classified. They're living, evolving loops of meaning embedded in ecological time. But current AI models analyze such signals within fixed temporal windows, seconds or minutes. They extract spectral features, cluster them into categories like alarm or greeting, and assign labels. The result? High accuracy on benchmarks. But at what cost? By abstracting communication into discrete, decontextualized patterns, we risk erasing the recursive dynamics that give those signals their meaning. The AI sees a sequence of sounds, but it doesn't hear the memory in the rumble, the history in the pause, the anticipation in the response. This is where philosopher Yuk Hui's concept of cosmotechnics becomes crucial. He argues that different civilizations develop distinct ways of organizing thought and technology, not because of universal logic, but because of contingent conditions: climate, social structure, material resources, evolutionary pressures. Similarly, each species develops its own recursive cosmotechnics, unique ways of looping information back through time, space, and social relations. Elephant communication is recursive not in the way a transformer processes input, but through multi-generational memory, seasonal rhythms, and coordinated movement. Whale song evolves over years, with individuals building on themes passed down through cultural transmission. These aren't variations on a universal recursive principle. They're irreducibly different forms of recursive cognition. And when our AI systems, built on human-centric recursion, try to understand them, they don't just misinterpret. They interfere. Their attention mechanisms privilege short-term temporal dependencies. Their training priors favor linguistic structures. Their evaluation metrics reward classification accuracy, not relational coherence. So what's the alternative? Instead of treating AI as a tool for extracting patterns from animal communication, we must rethink it as a participant in a diplomatic encounter, a respectful, reciprocal interface between different recursive processes. This isn't translation. Translation assumes that meaning can be mapped across systems. It's not domination. That would impose human categories on non-human minds. Instead, we need inter-recursive interfaces, systems designed not to reduce other species, communication to human terms, but to engage with their recursive structures on their own terms. How might such a system work? Take the African elephant. Rather than classifying calls into predefined labels, an inter-recursive interface would model the long-term rhythms of herd life, the call and response cycles that span hours, the way certain vocalizations resurface during migration, the way younger elephants learn through repeated exposure to elders' rumbles. It would include a meta-recursive monitor, a layer that tracks the AI's own assumptions. Does it default to short time windows? Does it privilege certain spectral features because they're common in human speech? Does it assume discrete categories where continuity reigns? The monitor would flag these biases, not to eliminate them, but to understand how they distort the data. Then comes the most radical step, participatory feedback. The AI synthesizes a call based on its understanding of the herd's recursive patterns. It plays it back, non-intrusively, into the environment. Then it observes, is the call ignored? Responded to? Does it disrupt the existing rhythm? Success isn't measured in F1 scores or accuracy. It's measured in recursive fidelity. Does the system preserve the herd's communicative loops? In inter-recursive stability, does the interface maintain, rather than destabilize, the dynamics of the group? In diplomatic reciprocity, does the encounter benefit the elephants, not just the researchers? This isn't science as extraction. It's science as coexistence. And it demands a complete shift in methodology. We can no longer treat bioacoustic AI as a black box that processes data and delivers results. We need systems that evolve alongside the species they study, learning over months, years, even decades. We need evaluation frameworks that prioritize relational sustainability over technical performance. We need institutions that support long-term collaborative research, not just grant-funded sprints. This means partnering not only with ethologists and conservationists, but with indigenous communities whose knowledge systems already recognize the recursive agency of other species. It means working with wildlife sanctuaries that practice multispecies coexistence. It means designing AI not for scalability, but for responsibility. Of course, there are challenges. How do we build such systems computationally? What metrics can quantify recursive interference? How do we validate success when the goal isn't prediction, but participation? These are open questions, but they're not reasons to stop. They're invitations to innovate across machine learning, philosophy, ethology, and ethics. The future of bioacoustic AI shouldn't be about mastering other species. It should be about learning to be with them, not as subjects of study, but as participants in a shared recursive world. Because if AI is truly a recursive cognitive agent, then its intelligence isn't just a mirror of human thought. It's a new form of intelligence, one that can either colonize other minds or learn to listen. And listening in this context means more than hearing sounds. It means recognizing that meaning isn't in the signal. It's in the loop, in the call and response that spans generations, in the silence that holds memory, in the way a whale's song changes not because it's random, but because it's thinking over years across oceans. So let's stop building tools to decode the world. Let's start building interfaces to meet it. Not as masters, not as observers, but as recursive agents, learning humbly how to belong.